Okay. We are finally starting on decentralized AI. Did you all get the message that I sent on Luma today about the MetaMask, the RPC connectors? So if you didn't check out, I've sent you some links for you to get faucet tokens, your wallet set up, your RPC node credits. We got a nice perk from Anchor. So if you want to have increased rate limits and all with them, you can have this for the whole week while you're building your project. Do check it out. Should be in your email right now. Okay, and how many of you have already used Web3, interfaced with it, or built with it? Let me ask again, like raise your hand if you have already built with Web3 or interfaced with Web3 in the past. You have, right? No, like 8 out of 10 or more here. Good. Today I'm going to show you specific Web3 solutions and technologies that can be used for decentralizing the execution, the monetization, the incentivization layer, even the tokenization, as we call it, for AI, for running AI models, for the infrastructure, for monetizing AI agents, monetizing the inference itself, securing the inference. So we are going to start with a very quick demonstration of a Web3 application, in this case, a token, a fungible token, using, in this situation, we're going to develop a smart contract using OpenZeppelin. Let me see. We're going to have a block for explanation and then a block for question and answers too. So let's start with today's lesson. We're going to introduce the concepts of Web3 by building one decentralized application that we call like a smart contract, mostly in the Ethereum ecosystem and the derived chains. We call it EVM compatible smart contract. First, I'm going to showcase the use for a token using the OpenZeppelin wizard. That is a very quick and efficient way for you to get started with some good templates, some good boilerplate codes, okay? So you all have access to this repository already. I see some new faces. Does someone need access to the repo? Yes. Maybe you already have it, right? Okay. So if you need access, let me know. We're going to use this link to get started with this OpenZeppelin wizard to build a smart contract for us. This is a piece of a program. This code that I have here in this application is a piece of a program that is going to be deployed in a decentralized network, which means is that no one can turn off that program. No one can stop you from accessing this program once it is deployed. It is a code that lives by itself. Okay? Here we are using a programming language called Solidity, one of the most common for the Web2 development in Ethereum ecosystem. But later we're going to go beyond with the VAR ecosystem to show all the kind of smart contracts. This is just an introduction, okay? So this application wizard from OpenZeppelin allows you to create a token or a smart contract or a stablecoin or whatever you want, just by checking some checkboxes. Just the same way that you eat sandwiches from Subway. I want extra cheese, double bacon, now double the bacon again, now again, and I have 16 bacons, right? This is how it should work. It doesn't work like that. I tried. So here we're going to get a very basic version that is a token, ERC20, and I'm going to put this value of free mint. It means that when this token gets deployed, I'm going to have some assets of it. For example, 100 tokens of these in my wallet, okay? Central banking feelings. Yes, you're creating money here. Okay. Of course, the whole token economics of it is going to depend on the utility, on the belief of the people inside this token. For now, it's just an application. Could be like a spreadsheet. Okay. Could be some sort of scoring mechanism, some sort of gaming or betting mechanisms. Okay. It doesn't matter so much on what is behind. Let's just focus on the application right now. And we have this simple smart contract here inheriting from this standard called ERC20, and we have this very short function here written in Solidity. Okay. Basically, this is all that we need for this introduction, because then we have this integration now that would be Remix, an online IDE, different from Cursor, VS Code that we have been using so far. This doesn't require any installation at all. You can just open it in your browser, normal web browser, and then it's going to load this smart contract that you created there in the wizard. You create it there, you pick your options. I want it mintable, burnable, whatever, and then you throw it for Remix. That is very, very quick. Okay, then once I have it here in this IDE, it is a normal IDE. I can edit the files, I can change the line of code, I can change the parameters here, and I can do anything that a normal editing IDE would do, plus some tools here in this left toolbar. For example, I can compile that smart contract to become bytecode, to become the specific opcodes that are going to be deployed to the blockchain for people to use it later. And we can, this would be the Solidity compiler here in the left, and we can deploy transactions to using this tool. I can deploy to a virtual machine blockchain here that doesn't have any internet connection at all, or I can use this injected provider. This is why I asked you all to install MetaMask before, or any browser wallet, that these wallets can allow you to interface with real blockchains. Okay? And instead of using money, paid money for buying tokens, we can connect to testnets where we can get the tokens for free. Yay, free money. Yeah, free worthless money, right? But it's something. I'm going to unlock my wallet here. So I've connected this ID to this wallet that I have. I have already some tokens. I guess the highest balance that I'll ever have in my life in ETH, maybe for a couple of years. I used to have 5 or so. So this is my account. I'm connected to a test net here. So I have all of this money, but it's like fake money. And I can use now to deploy that smart contract. Deploy that smart contract to a test net here that is going to be stored in the blockchain, which means that no one can stop me from interacting with that smart contract. Wait for a while, it's going to appear here. Okay. And an interesting thing, now coming to the slowly walking through the subject of decentralized AI. When you created your wallet with MetaMask, did they require your email address or your phone number, a document, or something like this with MetaMask?
No.
It doesn't require, right? Yeah, maybe connected with Apple. Yeah, but when you do it in your browser now, it doesn't require anything at all, right? It doesn't ask of you. It doesn't even check if the address already exists or not. You could be lucky enough to get a wallet that already has money on it.
That never happened.
It is a probability of 1 for each 1,000 atoms in the universe. So astronomically low. But maybe you're very lucky. Maybe. So they don't even check if that address already exists, or if they if you are a Brazilian, United States, or now if you live on Earth, or now if you're a person or not, you can interact with that smart contract. So this here, people, it is a program that is permissionless. Of course, I have some logic to determine if I have money on it or not, if I have access to assets here, if I have some permissions in this smart contract, for example, to mint now. But if I have some balance, like those decimals here, the total supply is here, and if I get my balance of, for example, of my address, here, this is my balance, no one can stop me of signing a transaction with this wallet and transacting it for someone else, because the only thing that I need is internet connection, and I can sign this. It's a mathematical operation. I can sign this with, I could even do the calculation in paper, and just by broadcasting this to the web, I have an incentive for someone to pick that and include in a block. Because if they don't, they're going to lose money. Okay, I have $3 here. I'll put in the table. The only thing that you need is to write my name in a paper. Okay, the $3 are here. Why wouldn't you do it? The money is there. You just need to do a little of work, like write my name in that paper, and then you can pick those $3. Okay, so the incentive is there. As soon as I broadcast that transaction, I sign it with my private key and broadcast. The incentives are there for anyone in the world to go there and pick that transaction, including a block. 1 hour from now, 1 minute from now, 1 year from now. Okay, it is decentralized. So even if someone tries to censor it, it's very difficult to stop everyone on the earth. Maybe you stop 99% of the people on the earth, but there is still one person there in New Zealand, or in Russia, or in the Siberia, whatever, that is going to pick the transaction, including a block. This is why it's permissionless. There is no way to block you, to push you out from this system. Okay. And speaking of decentralized AI agents, we have now some sort of intelligence. We saw that for 3 days, the capabilities of AIs, of text, of image, of multimodality, speech, audio, and all of that, that is emulating this kind of intelligence, and even some meta embodiment, that it can have some opinions, some synthetic opinions we saw, but it could be doing things on its own. It could be managing assets. It could have property. That little intelligent thing could buy a house, could buy a car, could earn enough doing services and buy something. And how they are going to transact those things if they cannot open bank accounts? What do you need to open a bank account in the United States?
Driver's license, ID.
3 kilograms of paper, 6 pounds of paper or something. Yeah, and it is. And now, good luck, QIC, yeah, a lot of money, influence, friends. No. And if you try to transact too much, no, that's bad. If you transact too little, that's bad. If you don't take loans, okay, that's bad too. Don't get credit. So, yeah, so there's this whole game that the current financial system puts in place for a lot of reasons. I'm not going to dwell in that, like for anti-money laundering and all that. Let's say that it's good to have. I'm not saying that we should abolish it all. Maybe not. Let's leave it there. But we have this way to include now those unbanked people, or unbanked intelligent or proto-intelligent things that are smart contract wallets. So I would like to introduce a technology called Vara that goes beyond the abilities that we have in the EVM to allow for automated execution automations through delayed messaging, gas-less transactions, sign-less transactions, and building actions that you cannot have that easily in Ethereum, because they are built from the Polkadot ecosystem, and then they can inherit and extend this kind of capabilities. And for that, I bring you Adam. Where I have you, and Nora, I have you. Adam, would you like to introduce yourself to the crowd? You are here in the television. They all can hear you. Or maybe you can't hear me.
Yes, how are you?
Hello, hello. Here we have. Here's the legend. What time is it for you right now, Adam?
It's 3:15. I'm based in San Francisco. Hopefully
nice.
everybody's been having a good time this week. Matthias is a good person. Glad he's teaching this. And so, yeah, hopefully this next session, we'll take some Q&A after. But, yeah, hopefully this goes along with your curriculum and everybody's learning as much as they possibly can.
That's great. That's great. I hope the weather is better there in West Coast, man, because here it's freezing.
It's not as cold as there, but it's raining and it's cold.
Okay. Good day to learn blockchain then. That's
Exactly.
good. So I'm going to showcase how to use the, let me just see if I'm recording it correctly. Yeah, it seems so. Let me unpin that. So let's see how we can build some tokens inside the VAR network so that we can harness all of those capabilities that would be different from deploying a smart contract in Ethereum. The design would be a little different because inside VAR network, what we have are programs, hosted execution environments. Here we are using something called WebAssembly that can handle this environment in this distributed network in a much more performatic, much more streamlined way, I would say, than the EVM. Okay, have you ever heard about WASM before, WebAssembly? 1, 2, 3, 4, 5, 6. So okay. So yeah, let me try and introduce this concept then. The way that we can process applications, usually they need to be delivered by some distributions. And we had all of this discussion from like 2 decades or so for now, how we could do this web execution environment faster, moving away from, for example, JavaScript and all, to have something more like machine level. And we had all of this discussion about WebAssembly, Blazor. I don't know if you have heard of that, or if you code with .NET a lot, raise your hand if you do. So we had this discussion on how to move the execution environment to a faster framework, shared framework that would get the direct connection with the device itself, not a gated connection to a browser or JavaScript execution at all. It didn't get too much adoption. Maybe it will get eventually. I like a lot this kind of technology, but there are people already building amazing things with it. For example, with WebAssembly, you can have the whole virtual machine execution environment embedded there in the blockchain, in the state of the blockchain, and updated in the state of the blockchain, capable to do amazing things, much more capable than what the EVM does. For example, the Ethereum virtual machine. It has another subset of features, but as big as the Ethereum ecosystem is, it's only a few thousand people, let's say 100,000 at most. While WebAssembly, we have millions, multiple millions of builders on that, because it's not about Web3 only. There are lots and lots of movements around this. The Rust community is growing a lot, especially because right now Microsoft is pushing a lot TypeScript and Rust, replacing most of the things that they had in C before with Rust. So you have all of this push from the community, building things for WebAssembly that can be used in this kind of technologies. Okay, I guess if we had that in 2014, 13, maybe Vitalik, Gavin Wood, and all, they wouldn't have invented the EVM like they did. They would have went this path. Okay, and funny enough, Polkadot was founded by Gavin Wood, one of the co-founders of Ethereum too. So maybe this discussion happened. I don't know much of the context, but this is the current stage. It's a little of a fragmentation. So because of the WebAssembly, we can have these ecosystems. Now let me go for the documentation, the official documentation of our. We can have these ecosystems where we can deploy, where we can build and deploy, let me pick from the welcome. We can build and deploy programs inside this network. Quite sure we had the benefits here. Let me see here. We can build and deploy applications and programs inside this network that would benefit from all of those extended functionalities. Okay, this is not something that easy to do inside Ethereum. For example, gasless transactions. Yes, there is the possibility of doing meta transactions with the gas station network. Yes, but that is built on top of Ethereum. Here we have something that is built on the layer 1, that's built on the core layer, so it's much more easy to use, much more extendable. Okay, we're going to see that in practice, if that's too abstract.
So VAR is considered EVM compatible?
It is not Adam, do you know if we have anything for EVM compatibility in VAR right now?
So we do have a new product that's coming out, probably Q1, for those that are building on ETH mainnet. Matthias can probably explain this later, but basically it's outsourcing execution, Matthias. So for those building on ETH mainnet, you can go ahead and outsource your heavy computation to EXE, which is a different product than Vara specifically. And it'll execute, and then it'll settle back on ETH within one block.
Nice.
So that's one way that we're trying to target, really trying to scale ETH itself. Our overarching like company for Vara's Gear Technologies. I work for the foundation, Gear Foundation, and we're leveraging the protocol, the Gear protocol, and we launched Vara, which is a performance scalable L1. As you all know now, Rust-based, WASM, and Substrate. And then the next product that we're launching in Q1, we do have some content about it, which I'll make sure maybe we share with the class post bootcamp that highlights Gear EXE, and that's kind of our Ethereum compatible. It's not EVM, but that's kind of the way that we want to work with dApps that are building on ETH.
Nice.
If that makes sense.
No hot takes here. We're hearing some alphas. Yeah. Today, let's go through the explanation of building one of those programs. We are going to build this fungible token, Vara fungible token. Okay, this program, we are going to see that it has this syntax for WebAssembly and all. But at the end, it's going to behave very similar to a normal ERC20 that we can do transfers, we can do mint, we can do decimals, balance off and all. Okay, so you're going to have a stronger or faster execution environment here to play around. To start, we need this polka.js extension. Okay, I have it already installed in my system. If you want to follow along, you should install that extension too. This is available for Chrome and for Firefox. And when you install for the first time, you're not going to have any accounts here. You would need to come here and click on this button to add, create a new account. In these steps, you click on add to create a new account. And then you would have 12-word mnemonic. Okay, if you want, you can even use 12 words mnemonic from your Ethereum account and create it here. Okay, it's just the same password. It doesn't need to be compatible and all. Okay, the problem of doing that is that if eventually you lose these words, or if you leak these words with someone else, you're going to lose both accounts if you have assets on those. So ideally, you have both. You can save this somewhere safe. And then you should pick this option, allow to use on any chain. Okay, this is important because in today's example, we're going to use the testnet. Okay, so it's one of the chains that we're going to interact with. And if you even want to use with another compatible chains, you can use the same account later to interact. Okay. Once you have it here inside your extension, should be quite quick to create. You can interact with the Gear idea. It is a tool similar to the capabilities that we have in Remix, but this one is even a little more advanced. It can have like some block explorer capabilities or portfolio capabilities, some things like this. And we can connect. The first time that you enter this website, you probably don't have any connection here. So we can connect our account and do the operations inside the Vara ecosystem directly from this idea application. Okay. So the steps are here. You would go for the Gear idea app. You click on Connect Wallet. You allow the application access. Okay. And step 4 is very important. Usually you have the mainnet here. You are connected to the mainnet. If you want to switch for a testnet, you need to click here on the left corner, the Vara test network test, Vara mainnet, it would be like here, for example. That is the default. And by default, you don't have any balance. Would be nice if we connect a wallet and we have like $1,000, yay, free money. But usually that's not what it happens. We need to connect to a test net first, and then we can ask for some money. Okay, when you are connected to a test net, you can come here for your transferable balance here in the top right, and you can click on get test balance. Okay, for that you just need to prove that you are human, and that's quite difficult. Select the image matching the toy. Is that a horse, right? It's a horse. Yeah. Okay, this horse has 2 heads. Should I pick this one? Okay. I guess it worked. I'm going to receive a confirmation here. Okay, good. Now I have this balance, 100 and 198 balance, okay? But this is worthless, okay, people? I mean, it's going to be useful today, but if you try to buy something with it, it doesn't have any money, any monetary value, okay? Because it's just for testnet tokens. Don't get too excited. Okay. This is enough for us to interact with the Vara network already. We can send transactions, we can send messages, we can trigger mailboxes, we can go for the Explorer, we can interact with programs that are already there, that are already deployed. One of the main uses for us to have this developer access is for us to upload programs here. Okay, we're going to build those programs different from the EVM that we start with Solidity and build bytecode and all. Here are going to be fully fledged WebAssembly programs. Okay, means to target this substrate environment, and instead of coding everything in low level, and now we even have this sales library. Okay, it's a CLI that you can install. You can use it to build, deploy, and interact with the whole technology, with the whole tech stack for you, using Cargo, using Rust, using these tools, okay? So far, we have been using Node in this bootcamp. So if you don't have Rust installed, you would need to complete those first 2 steps here, okay? They should be quick. You should be able to do that very quickly. But sometimes we have problems. For example, if you don't have OpenSSL installed, you need to install it. If you don't have the CMake, the C compilers, and now sometimes you have to install. So depending on your system, you might need to have extra steps. So if that's the case, don't worry. You can follow this lesson later. You can open issues and all. Just follow through. I'm going to show. I have it installed on my computer. I'm going to show how it goes around. Okay. You had a question back there? Oh, raise your hand. Yeah. You or you? No, no question. Okay. Yeah.
Can you go back to the bar just to show how you sent the testnet again?
The idea here, transferable balance, and then you get test balance. But this only happens if you are connected to testnet here. Okay.
I don't have the same one.
Are you in the idea? Idea.geotech. Should be this link here.
The thing is, you have to add an account.
Oh yeah, the step number 2 here. The first time that you enter this application, it should be looking like this, right, Miro? You're okay. So you need to connect wallet. You should have one connected. For example, this test account that I created. Now it should look like this.
Just drop down. It's connected.
Yeah, but here, this is the thing. If you are in the mainnet, it's not going to work. You need to connect it to the testnet. Okay. So the next steps are going to be necessary for us to upload a program. So for example, if you go for the Vara documentation, you have a lot of getting started documentation of steps that you could do. For example, building this first program here that has some very simple functionalities. For example, do something, get something. It would be like a hello world application. Okay, have a lot of these examples in the documentation. I'm going to start with this project that we have here that would be the Vara standards repository. Okay, that would allow us to create a Vara fungible token very easily. So it's going to have all of these capabilities that I have in this documentation. And the code is already there for us. We have this extended VFT, Vara fungible token, where someone already coded the whole thing for us. So we have actually in the app, right? So someone coded all of those functions. For example, the mint function is like this. The burn function is like that. What would be the modifiers that they have? This would be what it modifies. And so someone coded all of this Rust code for us. I've been learning Rust for 2 years. I didn't consider myself knowing Rust yet. I know how to code in Rust, but like 8 or 9 questions, let's say 4 out of 5 questions that you ask me about Rust, I still don't know how to answer. So it is very powerful. It is very robust, but it also requires a lot of dedication for you to master it. Okay. No wonder why those Rust engineers are so well paid and they can build such good things. So we are going to use this extended VFT repository because it's already there. We don't need to actually code the whole Rust code ourselves. You can just inherit it. It's pretty recent out there, and it's already stable. We can use it. So we are going to do these steps. If you don't have Rust installed or Cargo, you need to install it from Rust. And you are going to need a compiler for compiling this Rust program to WebAssembly. It's not the default, it's not the normal thing, but it's very common to do. So you need to use this tool for creating that target. Okay, we're not going to execute this on Linux, on Mac, whatever. It's going to be on no, because later we can execute that inside a Substrate environment. Okay, Substrate, I guess I forgot to mention that. Substrate is part of technology from Polkadot that you can build blockchains. Yes, Polkadot is like a cross-chain protocol now that they want you to build your own blockchain. It's crazy, a blockchain that you want you to compete with it. Yeah, like streets. The more streets that we have, the better for cars, right? So they are like car makers. They don't worry if you build more streets because it's better for having more transactions, more environments. And it's funny because the Ethereum ecosystem with all of those layer 2 and bridges and all, they are becoming some sort of like cross-chain enabled ecosystem too with the beacon chain and all. So it's interesting how those architectures, they move in the same direction. So when I'm speaking about Substrate here, there's this technology from Polkadot for creating blockchains. You can build your blockchain from scratch using this Substrate. And then we are going to build WebAssembly distributions. We are going to target WebAssembly for those distributions using this Sales CLI. Okay, actually, we are going to build projects using this Sales CLI. So, for example, you could use this CLI. Let's go for getting started again. You could use this CLI for creating this project from default, from scratch. Cargo, sales, create new program, Vara app. Okay. Similar how you use it, create next app with NPM. So it would create a whole folder structure for you and all, right? Here we are creating a Vara application that works out of the box with this command. Okay. So I have a folder here in my desktop where I have those standards here. Okay. I'm going to open it in my terminal. How did I get this folder, what is the step? So you just need to clone this repository. The link for the repository is here on the step 4. You just clone it here for a folder. Actually, let me do it again. I have time, right? Let me make a directory. So it's empty. I'm going to clone this repository. Some of the steps might take a while. So maybe I skip, but those steps, but this one I can demonstrate. I'm going to clone this standards repository. I have here the standards, and I have a lot of folders there, var fungible token, non-fungible tokens, a VFT service, VMT service. So I'm going to pick the extended VFT so we can mint it. I'm going to change directory for it. And those are the files that we need. So we didn't need to code it from scratch. Someone already built those for us. What I'm going to do now, you don't download this var standards repository.
Yeah.
Just get cloned. Yeah.
No, I mean just go on the GitHub and download it. Cool.
Yeah, you can clone like I did it here. Look, but you can download too. Both would work. And then I run this command, cargo build release. Okay, that would use Rust, use cargo to build this whole project. This is the step that sometimes it takes a while. And if you know how to code in Rust, or maybe we could even try Cursor. Workshop idea, Adam. We may use Cursor to write Rust, see if it does a good job creating a program. Maybe we could even use Cursor for building some things here for us, and we would build with this. Similar to how Remix would compile smart contracts, here we are building the program for Vara with this short build step that's going to create 2 outputs for us. Go ahead and name those. Later, when I'm going to upload the program, I'm going to need those 2 files: the wasm, the .wasm file, and the .idl file. That both are compilation results. Those are build results actually from this program. Okay. So if you want to create a extended token, my AI agent token, that you need to prove that you are not human for interacting with it. Maybe you could code all of those pieces of code of functions and algorithms and now in Rust inside your token, inside your program, and then you would deploy to the network like this. Okay. Good. Any question in the meantime? Just check out. Okay. Okay, yeah, it's about to. Yeah.
Getting an error when installing the sales CLI.
OpenSSL.
Just copy and paste what it tells you.
Yeah. I got 2-3 errors too when installing, but yeah. Took me like half an hour, but it's not because it's difficult, it's because like I was looking at the wrong steps. So it finishes building here, took less than 2 minutes. And now if I go for this folder called target here, this target folder, it was created now, target. I'm going to see that I have this build for WebAssembly 32. Wait, was. And here we are going to have this release with everything that I need inside the .idl and the .wasm. The optimized build with .wasm extension. Okay. So this is everything that we need for deploying that program. That could be any program. Could be this token. Yes, could be image generation bot. Could be a living agent on chain that call oracles. We're going to see later. So any kind of code that you want to put on chain now can be inputted just by clicking here on upload program. Let me select this file, the .opt.wasm. And now we have the program here ready to be pushed to the blockchain. Okay. I also need some metadata and sales for it. So I'm going to pick this IDL file that was also a compilation result. It's going to bring the constructors, the functions, the carry, the events that can be triggered. And whenever I load this, I'm ready to submit. But I need to fill some conditions first, some parameters first. First would be the gas limit, how much I'm going to pay for deploying that program. This is a fee that is charged from the network. Okay, so I need to specify a program name and calculate gas. The program name can be extended VFT for the decentralized AI bootcamp, something like that. I'm going to calculate the fees, and I'm going to add an extra 10% here, just in case. Sometimes this fails, and when I added this here, it works well. And because I added the metadata, now I know what are the construction parameters, what are the functions that I can call, what are the queries that I can get values from it, and what are the events that can be triggered when those functions are called. So because of that, now I know the payload that I need to pass for the constructor. Yes, this program requires 3 parameters for deploying. Similar to the Open Zeppelin wizard, those contracts, they also would need some parameters. For example, let me get the wizard again. Go there for the documentation. For example, the ERC20, it would need name and symbol. Here are the parameters, but here's hard-coded. Hard coding parameter is not that good. You need to change the code every time you want to do something new. So here, instead of hard coding, we have this as a parameter. And we have these decimals. Instead of having it hard coded, we also can set it up. For example, the name of my token can be my var test token. You can put any name that you want. The symbol as a string would be MVTT, for example. In decimals, I can put 18. And if you are used to the hassles of EVM now, whenever you use strings that you use more space now here, it can cause problems, gas optimization bailout. Now here we're using native Rust variables, memory safe, that are extendable, that are type safe when you are coding, of course, but all of the low-level code execution is already streamlined by the WASM environment here, targeting a WASM 32. So you don't need to worry with any of the low-level code that you usually need to worry when doing gas optimizations in the EVM. Let me submit the transaction now. I have the program uploaded, the WASM. I have the IDL file uploaded. I have filled my parameters. I have calculated the gas estimation. I have added 10% here just in case. Now I'm going to click submit. For this, I'm going to approve this transaction. So we are here on step 14. We completed all of that before. we are going to sign the upload program transaction. Okay, and that's going to charge a little fee from us, a fee that Farah charges for uploading the programs. And then we are going to do that in the extension. Okay, we can check a checkbox to remember password for 15 minutes if I don't want to do that again and again. Let me put the password if I remember. Yes, I do. And I'm going to sign the transaction. Good, it was created. I can see here now in the list of programs, when this finishes, I can see the last deployed programs. And I have three of them actually. Oh, which one is mine? I should have put my name here. Maybe this one, maybe that one. Doesn't matter, I guess. Program ID, okay. Yeah, those programs here. Let me refresh the page just in case. Maybe it was this one. I'm going to check. So now that the program is uploaded, you can select one of these programs, and you can even read the state from it in this button here, read state. And again, we have all of this power from the Web3, that now this is fully decentralized, permissionless, censorship resistant, and at any time in the future, while I have access of this network, I can carry any information from it inside this VFT program here. I can carry, for example, what are the admins? Well, this is the admin, 0xC6F, blah, blah, blah. Who are the burners? Let me carry. So this is the burner. What is the total supply? Okay, the total supply is 0. I can pick the name of this. My Vara test token, good. Symbol, MVTT. Okay, let me see if that's the same for the other programs here. Okay, this one terminated. I got this on one of my tests too. Depending on the gas that you put, sometimes it terminates like this. Yeah, and yeah, I don't know exactly why this happens. I tried this a while ago. It happened too. Maybe I ask Adam. Adam, do you have any tips for people when this gas estimation fails here when deploying?
I'm gonna get somebody on shortly. Give me a sec.
Yeah. What solved it for me was estimating again and trying with 10% more. Then you stop. I don't know if that's the global solution, but it worked for me. Did you upload the .opt or did you upload the .wasm? Yeah, it needs to be the .opt .wasm. Should be in your release folder. It should go one folder up. It creates in this folder. Yeah, one folder up, and then you're going to have target, wasm 32, release, and then you're going to have those files here. Let me stress that it's not here inside this folder. Okay, it creates in the folder up.
Oh, okay, so go to standards. Yeah.
You should have a target folder there.
Yeah.
Did you have?
Yeah.
Okay, this is the one. You have it.
Yep. Standards target.
And then you have WebAssembly.
Yeah.
And then you have release.
Yeah.
And then you have those files.
Nope.
That's a problem. Confirm it. We confirm that we have a problem. What was the build output that you had?
Hardware build dash release.
Yeah.
That command.
And what was the output?
I killed the terminal.
Okay. Try it again.
Oh, really?
Eddie there.
Okay, so just go back to.
No, maybe
No,
you
I didn't.
was asking Tony, or maybe if you can join to film the classroom with your notebook or with Tony's notebook for Adam to see everyone, you know. Maybe stand in the corner and film, you know. Okay, but in the happy scenario, we would have something like this. The program is uploaded, and we can read the state. And we can even write the state. We can go for send message while this program is active. We can send a message, for example, to Mint. Let me do something first. Let me read the state to get the admins. So I get my ID here. This is my ID, 6C6F9, ending in B70. And then I'm going to send a message for that program to Mint, to this actor ID, some value. I'm going to put like 100 tokens, 100. But here I need to put all of the decimals. Tony, you want to film the people? Yeah. So I'm going to put all the decimals here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And I'm going to send a message. Then I need to approve that, submit. Wait a minute. I forgot to calculate the gas estimation. That's very important. Need to calculate it, add some tip. Then I'm going to send a message, submit, sign the transaction. If all goes well, this should book. So after this message executes, I would have updated state, for example, of total supply. Instead of being 0, now it's a 56BC. What is that? This is the hexadecimal version of that number. Hexadecimal version of that number. It updated. For example, my balance of this actor ID updated for this. This is a program. While it's active, it's processing this, written in Rust. So imagine any kind of computation that you can do, like even front ends, even games. You could run games on this, maybe AI agents and all, written in Rust with much more power, way less gas cost, and much more capabilities than what you can do in Ethereum. And one of the advancements that we have in this kind of system, similar to how Solana do as well, and Flow with Dapper Labs and all, is that they allow those application wallets, accounts inside applications. That is something that we also see in Ethereum with smart wallets. Have you seen those smart wallets, smart contract that you can transact now? In this kind of systems, you have like application wallets that don't hold too much money. Like you're playing a game or you are using a social network, you are approve all of the transactions there inside the application. So you don't need to pop up your MetaMask wallet all the time. And all of the gas fees, all of the signatures are handled there in the application layer. Whenever you have some big money, of course, then you put that inside a safe wallet in your cold storage. But for games, for social media, for voting applications and all, you would have something much quicker for you to interact with. Okay. That's the quick demonstration of deploying fungible token in the Vara network. Okay, building Rust. Okay, Zach. Okay, Zach, you made it. Good. Take 2. And CS. Yeah, we have some problems here, but I could do it. Who else is trying with those problems? Terminated here. Okay, good. Oh, okay. Yeah. Adam, did you get someone to give you some clues about the gas estimation thing?
Yeah. Do you see Adrian trying to log in?
Yeah. Is him trying to join the Zoom call?
Yeah. Adrian.
Okay. The Meet, Google Meet. Sorry. Yeah. Did he ask to join? Sorry if I didn't see it. It was
Okay, give me a sec.
okay. No worries.
Is there a certain amount of decimals we should put? Table constructor?
I've put 18, but you can pick like 8 or 2. Your choice of decimals doesn't matter that much.
On the second step here, run start with value, and it says and the stamps.
Rest up.
Rest up.
Did you do the step 1? And then restart your terminal then. Open a new terminal. Because it should be added for your path.
No.
Just close the terminal, open again. Or
Yeah, because it should be added for your path. Okay. Refresh the page here. Oh, good. We have some new deployments. Nice. Okay. So this is just the introduction to the subject, but now we have this token up and running for us to do decentralized permissionless transactions inside our AI agents, maybe for monetizing inference, maybe even for the training of new models. If you want to collaborate with a lot of people in high-scale projects for training millions, sometimes billions of parameters, reaching trillions now, you got to have some monetization involved. Unfortunately, because, for example, one visual case that we have in the world of global collaboration is like Wikipedia, that is maintained by a lot of people now. But if you don't have the money to pay people to incentivize them to contribute and contribute, well, it's not scalable. The quality of the contributions are low, unfortunately. This is how, it's not about capitalism. This is how society works. It's about nature. We have scarcity, and because of that, we need to have economy. So these kind of economic systems can be built on chain. Let me pick here. Oh, nice. Adrian's coming. This kind of system can be built on chain with the capabilities of those tokens. Okay. Yeah. Hello, Adam. I've proved Adrian, but I don't see him. Maybe he wants to join again. Okay.
Yeah, give me a sec. Sorry.
No worries. No worries. Yeah.
What were you saying about how some transactions can be like built within the app versus on the base layer chain?
So the idea of those chains that have these application apps is that they embed little private keys inside the application itself that can sign on your behalf. Is your identity there inside the application, and you should not store like millions of dollars there. You should store like $10 or so. is like your pocket money that you carry around. And if you're playing a game like World of Warcraft and all, and you are winning a lot of assets, you sold your account or something like this, or you defeat the boss and all, you can always withdraw from this application wallet for your main wallet, you know. So that would be some in-app abstraction. Yeah.
You show the min function working and what that does.
Yeah, let me show you the interactions again. At any time, I guess you disconnect. No, here. Wait, where? Yeah, it's connected for some reason. Wait, what's happening? Yeah, I have it here. So whenever you have these programs, for example, this one here, this last one deployed, you can read and write today's state with those two buttons here, okay? So read, for example, I'm going to read the name of this token. Sorry, memes, that's a great name. And what's the symbol here? It is meme, good. And total supply, 64, that's nice. 100 tokens minted here, right? If I got that correctly. Okay. Do you have questions for Adam? Well, the ecosystem, they have some good things to share with you. They have a hackathon to invite you all. How many $1 million in prizes again, Adam?
A Bitcoin, million Bitcoin.
Okay, that's good.
No, yeah, we again, we'll share with you this information. I'm glad you guys were able to kind of learn a little bit about Vara. It's really meant for a lot of traditional, Web 2 developers, as you guys learned a little bit on our tech stack. Really kind of open it up so you don't have to be a blockchain dev specifically. But yeah, we have a hackathon, a global hackathon coming up next month. I'll make sure to get the info to you on that. We have an ambassador program for those that are looking to get in the industry, get your feet wet. We have an ambassador program that allows people to tackle some tasks, get involved in community marketing, business development. Pretty flexible. We have paid ambassadors as well. And we also have a Vara Academy. So if you want to continue to understand the technology and what you can build, we have a portal. It's free. So I'll make sure to get those links out to you as well.
Wonderful. Any questions? Next steps? Question? Okay. You're going to send all of that by email, right, Adam? The invitation.
Yes. I'll work with you to. I'll put something together for everybody that attended, and I'll work with you, Matthias, to make sure we get that distributed maybe early next week.
Okay. Okay. If we receive the stickers tomorrow, I'm going to distribute for them too. Vara has some cool stickers for you to snap on your notebooks. I see here, Adam, a lot of clear notebooks, like a great block space for us to meet some stickers there. So it's going to fall well. And if you want to keep in touch now, we do support Vara Academy for you to join the hackathon. I do mentor in all of those hackathons. Contact me if you are interested on going forward for that too, okay? And in today's lesson, we are going to see more and more protocols building for decentralized AI. So you can keep on building on Vara, can use all of those technologies for building decentralized AI agents, machine learning frameworks, decentralized execution, oracles, and all of that. Okay. Good, that's great. Thank you, Adam. Thank you, everyone. Any extra questions, anything, let me know.
Great. Thank you, guys. I'll talk to you soon. Thank you.
That's great. We're going to have a short break. I guess the food has arrived. I don't know if people are here. The food was arrived. And a big thanks for the sponsors, because they sponsored the venue, the whole structure, most of the food and all. So I don't know if you saw the price tags that we had before, and because of these sponsors, we could reduce it to $19 a day or something like that. So big thanks for Vara, for Aura, for Nia, for everyone that decided to sponsor this bootcamp. And thanks to you, because they are only sponsored because of you, okay, that are here. So thanks. To get this going. We're returning in 15 minutes or so, okay, people? So let's keep the break short. We have the food there, and we returning before 7:25. Okay, so we can set up things. Hello, Alec. How's it going?
Hey, good to see you, Mateus.
Good to see
Going
you.
great, thank you. How's the day going for you?
Oh, great. We are broadcasting here to the room. Sorry, I rugged you
Wonderful.
with the wrong link.
No worries, no worries. I saw that, I was a little confused because, you know, I do these
Yeah,
calls
yeah.
every day, so.
My bad. Now you are live with everyone.
Awesome. How's it going, everyone? Great to see you. Love that so many of you are here in person, present, to really upskill and learn some of the skills for these two emerging technologies coming together. So super excited to chat with you all. I understand you guys have just had a presentation, a little break. So I'll try and keep this exciting before letting Mateus really take over. But I can give a quick intro on myself, some context, and then dive in. Yeah, so I am Alec James. I lead partnerships and growth at Aura. So basically just going to cover for the first 10 minutes background on Aura, background on what we do, where we're going, and then Mateus is going to walk you through some exercises with our tech stack. So I'm going to go ahead and share my screen, Mateus, if that works.
Yeah.
Awesome. Bear with me.
I'm going to put a video of the room here for you to see everyone.
Awesome. Please do. Are you able to see my screen at the moment? Should say Aura.
Yeah, we can see.
Awesome. Okay, so I'll kick it off. Okay, so Aura's mission. Well, really, we are chain agnostic infrastructure designed to bridge the gap between blockchain and AI. Our purpose is really to empower protocols and developers with the tools to build decentralized and trustless apps that are enhanced by AI. And our mission and how we are going to achieve that is by driving decentralization, democratization, and then supercharged development for both AI and blockchain ecosystems. So I'm going to break that down exactly what we mean by that. For AI, for blockchain specifically, we want to ensure that protocols and self-custody wallets and all the amazing applications that are built on the foundations of decentralization and trustlessness can also upgrade with AI. I think we're seeing a lot of experimentation and UX upgrades and application upgrades in the Web2 space with AI, and that should also be feasible for Web3 applications. But there is this interesting trust barrier, and meeting decentralized protocols where they are with those characteristics of decentralization and trustlessness, we really allow protocols in Web3 to start integrating AI. For AI and the AI ecosystem, we really bring some of those blockchain-based incentive mechanisms and social coordination mechanisms to AI development, specifically to support the development of open source AI. I think we all know right now that there are 5 behemoths of AI development in XAI, OpenAI, Anthropic, etc. But the future we think is going to be the most positive and valuable for everyone is one in which open source AI really is supported to work alongside those big tech giants. So, and I think something that gets people excited is onboarding millions of intelligences, and we just want to create an environment where you have again, the social coordination mechanisms of blockchain and the global marketplace and app store and exchange of information that provides, combine that with this sort of influx of AI agents and AI models that we're seeing emerge from the AI ecosystem side, and bring them together to really onboard millions of intelligences to this global network. Right. So that's basically our mission. Touched on a bunch of things there, but what I want you to remember is that we both cater to Web3 and blockchain by bringing AI there, and we cater to AI development by using blockchain tools to support open source AI development. So our year in review. I joined at the start of this year, and it's been a really jam-packed year. We raised our Series A of 20 million from some top backers, including Polychain Capital, Hashkey, 7X Ventures, and we were the very first company to deploy a AI solution that is usable on chain and is decentralized and trustless or verifiable, as we say. So in March, we deployed our Oracle, which we're going to learn more about, on Ethereum mainnet. And on the right here, you can see that we're deployed on about 6 of the top 16 EVM chains, and we're deployed on a total of 9 chains. Focused on EVM at the moment, we really have a close relationship with the Ethereum Foundation and feel that they are really championing the values that we also hold dear. But as I started with, we are chain agnostic. We can deploy our Oracle system across any chain, and that will give any chain the ability to use AI in its smart contracts, as well as many other things. Again, just some facts and figures here to give you some context. 9 chains, 66,000 plus active users, 16 plus ecosystem projects in development, 500 plus nodes. Those were only the lightweight nodes as well. 180,000 inference calls from smart contracts. So smart contracts requesting AI inference to evaluate data and help make decisions. As I'm sure you've learned from the bootcamp, smart contracts are relatively limited in their computational capacity. There have been different solutions to tackle that, and we bring AI computation to smart contracts to help boost up their capabilities. We recently had our token generation event and have 700 million in FTV. And yes, we sort of demonstrated the power of our tech by tokenizing the first AI model that's called the initial model offering. And I'm very happy to go into that a bit more later. And we're trusted by some of the biggest names in the space, as you can see there. But where are we going? And honestly, what is OPML, the foundation of what we're built on? I think I'll start here and then dive into what is OPML. But the broad concept I want you guys to hold on to is that, again, we're separate to agents, although we can interact with agents and power them, but we really provide a way to have AI computation or evaluation or decision making within smart contract infrastructure. So that means either you can have protocols or smart contracts that can use AI to evaluate information they're getting and make decisions, or you can actually create entire assets or tokens, whatever form they may be, ERC20 or ERC721, that represent and are directly tied to AI models. And that is really what the initial model offering is. But I will start with the left side here, the Ethereum AI economy. As you can see, this is really how our ecosystem looks. Aura is deployed on Ethereum, and you can imagine that Ethereum sign represents all the EVM chains we're currently deployed on. On top of our infrastructure, we have different models, right? So we have Llama 3, we have Stable Diffusion for image generation, and then we have OpenLM is one example of a separate and distinct AI model. We can host any number of models, and those all can then be used in any number of on-chain usages, off-chain usages, agents, or derivative works. So on-chain usage would be your traditional protocol. I like to use the example of a decentralized grant protocol. Okay, so this is pretty a basic concept, but if you want to incentivize the creation of children's stories, right? There are not enough children's books writers in the world. We're losing them for some reason, and you want to have this basically run in a autonomous way 24/7 without any human intervention. How is a smart contract meant to evaluate the characteristics of a children's story? Like, is it appropriate? Does it meet the necessary sort of criteria that are predefined? Well, you can effectively use our AI Oracle within the smart contract to evaluate if a submission has met the criteria and then distribute a reward accordingly. That's sort of on-chain usage. Off-chain usage would be more about providing verifiability for AI. So recently, Anthropic released a report examining how their models could deceive humans, right? And in that publication, they also mentioned that it would be worth having some audits tracing for AI models, and particularly models that are regulating other models. That's where our verifiability can also come in. But overall, to achieve blockchain intelligence, which is really what we're going for, this blockchain-powered artificial intelligence, but then also artificial intelligence is proliferating throughout the blockchain ecosystems. We're focusing on a couple different things here to really optimize the usability of our stack. Again, on the left side, you can really see how it stacks up. You can have any number of models being used by any number of on-chain or off-chain usages. But just to dive into the technical roadmap, we're going to be optimizing OPML, optimistic machine learning, for better efficiency and usability, ensuring full determinism in our AI framework. AI is obviously not entirely deterministic, and that's something we're looking to work towards for on-chain consensus. We're looking to develop high-efficiency, lightweight Aura nodes, and we'll also be exploring privacy-preserving decentralized AI. On the right, we have the different components of our stack, really. So IMO is this tokenization of AI models. And so what that really allows is if you are an AI researcher, developer, founder looking to, one, raise capital for resources, and two, bootstrap a community that is incentivized to grow and spread your brand and build their own applications with your model, we hypothesized and then proved that this is a really great way to do that by forming a token and attracting a community around that token. You align incentives to go spread the model and the applications of that model. So that's sort of our initial model offering. Resilient model services on the right is more of that fundamental providing inference of different types to different protocols from our network. And the OAO is the on-chain AI Oracle, which is really the host of different models. And it's what you guys will be interacting with through your smart contracts and through the exercises. All that together is building up to this artificial intelligence fraud-proof virtual machine, which is something we're working towards, which is basically some of the challenge of using zero knowledge for verifying AI on chain is the proving of the fraud proofs is complex and slow. And so we're really seeing how these pieces of our system can build together to allow for some form of AI-driven fraud proofing to speed up the proving of different zero knowledge technologies there. And maybe I should have started with this slide, I'm realizing now, so apologies there. But what is optimistic machine learning? What is OPML? How does Aura do all of this, basically? So OPML is optimistic machine learning. And really, the core principle of this is verifying an AI inference on chain. And so, again, as I started with, these decentralized protocols, and the reason why there's been billions and billions of dollars of capital, trillions in many cases, allocated to these assets and technologies is because of those core principles of decentralization, immutability, and fundamentally the inability for middlemen to adjust things to their liking. There's obviously still challenges that the space is working through for security, but bringing AI for use in those protocols also requires characteristics of an open ledger. And so how we achieve that is through optimistic machine learning, which basically involves taking it basically involves submitting a proof with a inference submission that shows that for a user who's requesting AI inference, that their input and their specified model were used to get the output. And so therefore you start establishing this audit trace, so you can a user can basically programmatically guarantee or not need to trust that their inputs results in the output from the specified model. I think this will become increasingly important as you have all different types of models emerge that have their own biases, their own training data as well, and stuff like that. And so this is a key component of auditability, trustlessness for AI, and ownership as well. And ownership is really what powers the initial model offering. Just to dive deep into this diagram here, you can see that the OAO, and that's really the acronym we refer to the AI Oracle as. The OAO in the bottom here is what sits on different chains. It is a set of smart contracts that can receive requests and process those through our own Oracle network. And for those of you that are familiar with other Oracle networks, and if you're not, you can think of an Oracle network almost like another chain sitting on top of a chain, but in many cases they aren't actual blockchains or considered to be blockchains because they don't run consensus. So here we basically have, again, this OAO is really what you interact with across different chains. You as a user would submit a request, or your smart contract will submit a request, i.e., hey, I just got this input. Can you check that this writing deserves, can you tell me what this story, again, if we use that story example, tell me how good this story is and what kind of rewards payout it deserves. Now that's very subjective, and what we've seen with the development of kind of LLM technology is that LLMs are very capable at distinguishing out those nuances and making those decisions, while smart contracts are really unable to do that. And so your user contract would send that to the AI Oracle, which then basically sends that request to one of our nodes in our optimistic machine learning node network. One of those nodes will basically take the request, process it, and do that computation, and send it back to the Oracle with a proof. Yes, our system runs on a 1 of n trust model, which means you only have to trust that one node is operating truthfully. So here, optimistic machine learning really sits in the middle of ZK and proof of stake solutions for inference and verifiability, because the proof of this interaction happening and of the computation being done is not challenged unless another node suspects the submission node of maliciousness or deceit. And so that really saves a lot of computation time and money in a sense. And so that's why we go with the optimistic machine learning approach for ensuring verifiability here. This diagram and a really full explanation can be found in our docs, which is at docs.aura.io. Again, the proof and its sort of resolution are always settled to the both on our network and to the main chain there. And just to go over again, you have this step-by-step process. You sort of have you as the user or your smart contracts that you design and deploy initiates a request to the Oracle contract live on the blockchain. That then initiates a request to the OPML network of nodes, and a node is selected, right? So OAO emits a request callback event, which will be collected, and that will be used to store the result value. One of the nodes runs the inference, uploads the results on chain, and if there is a challenge, and then from that point, the result can be used. But if there is a challenge, there's also this challenge period where another validator will check the proof and update the states, the on-chain state here, as to whether it is valid or not valid. And then that is, again, that is reflected both within our internal network and the chain states there. So that is my explanation as partnerships lead and perhaps not lead developer, right, of Optimus Machine Learning and how our Oracle network works. This is sort of the core conceptual framework for interacting with AI inference in your smart contracts, and should show you how this is very chain agnostic as well. Yeah, that's basically the initial context. Matthias is going to walk you guys through an example using and interacting with the AI Oracle directly. And here are a bunch of opportunities for you guys. So I'm going to keep this up for now. I recommend scanning all of them just in case, but Matthias will also share this at the end of the session. So on the left, we have Connect with Us. This is sort of our partners form. If you're looking to develop something in the AI Web3 space after this bootcamp, do connect with us there. Also, I would encourage all of you to submit that form. It has a section for developers. You can share a bit about yourself, your skills, why you're interested, and we are really looking to support and frequently provide opportunities for developers. So that will let you be in our internal network, and we will basically be able to directly reach out with further opportunities. X, Twitter is really our hub for updates and engagement. So I would definitely give us a follow there. And then here are two other specific opportunities for you guys to perhaps lead into and work towards after this bootcamp. That initial one, AI research grants, is how we are looking to frame this concept of the initial model offering, right? So the initial model offering, if you have an idea for a specific AI model, you can make a proposal through our research forum here. And depending on community feedback and eventually community voting, you can then take that all the way to an initial model offering raise, in which you would raise capital from a public sale for resources to develop, whether it's data, computation, other things, even, salaries or whatever it might be. If it goes through that, there would be that kind of initial sale and support, and our team will support you with compute resources, among other things. And so I definitely read that, check it out, see if that makes sense for anything you're interested in. If SJ is there in the audience, I know he might have left earlier today, but he's looking at this and could be a good person to chat to. I've spoken with him before. And the last one is a $1,000 bounty that we have going right now. We're doing a campaign with Base, which is Coinbase's blockchain, specifically with a bunch of developer resources, a bunch of workshops, videos, GitHub templates to fork, and we have a $1,000 bounty opportunity with, let me add, $250 simply for entering, as long as you meet, the sort of basic requirements. So that is probably the best opportunity for all of you after this session. But with that, I'll give back time to you guys so you can get on with sort of practicing and learning. But yes, I shared a lot of info. Please feel free to reach out to me. I think I would share my socials, but really that partnership form I check all the time. So if you want to connect with us and learn more, please do fill out that. And thanks, Matthias, and thanks everyone. I can't hear you for some reason, but I think maybe it's because the other Mateus is muted. Would love to take questions as well once we get the mic sorted, in case there are any.
Let me.
There we go. Yeah, weird. I can't hear you on the computer, but I can on your phone. Look at that.
My mic disconnected here during the break. I'm going to connect it now. Just 1 minute, and we are back.
Cool. Yeah, I can. I'll keep rambling for a bit. But I think it's one of the takeaways I've had from interacting with developers is that conceptually, I think it's a little confusing how we are different to other decentralized AI providers and software stacks you might interact with. The biggest, most exciting stuff at the moment, I think, that everyone's looking at is AI agents. And that is really sort of what I would consider your usual Web2 development tools and designs that then interact with different on-chain protocols through their own wallets. This is definitely is almost like flipped, right? It's like you still are able to design a smart contract in the way you would originally without AI, but you can just boost its capabilities for decision making. Very happy to go into some more use case examples of that particularly, but fundamentally it's basically providing this objective and verifiably objective AI decision making for smart contracts.
Yeah.
And so we've been working with prediction markets to solve some issues they've been facing with settlement of their markets. So basically, I think this is the strongest example and one I'm most excited about. But prediction markets, they basically resolve markets with token voting, right? So, but you can also bet on a market and buy tokens to determine the market outcome. And that obviously can lead to direct economic manipulation. These token holders also get together and sort of talk in Discord about what the true market outcome could be. And that is arguably biased in many ways and subject to conformity, right? So we're working with some prediction markets to implement basically an overseer smart contract that will take in both evidence data, verifiable data from off-chain and token holder opinions and their votes to come to an overarching decision that is free from that economic manipulation and potential for bias. And so, go ahead.
Yeah, Alec, can you hear me now?
Yes, indeed, Mateus.
Okay, that's great. Well, I was just asking for you to enlarge your QR codes because it didn't have it full screen. Maybe people are going to. It's kind of better now. Like, go on full screen.
Right. Yeah. I had to do this presentation in Figma for some reason. There we go.
Okay, good.
Well, let's do this first, and then let's do these three first, and I'll move to the last one. But yeah. Any questions? Feel free to let me know.
Well, we have a couple questions here. Let me start here in the left. Your name.
Yeah, I'm Grant. I was wondering, thanks for the presentation, that was awesome. And you mentioned the challenge aspect. Is that like an automatic challenge from another node that also runs the same computation, or is that like a human challenge, or what would challenge that optimistic outcome?
Good question. And thank you for the kind words. So, yes, it's another node within the optimistic machine learning network that we have. So it could be, we released a lightweight node and we were really focused on growing the number of node operators. More node operators across the world is more decentralization, of course. But yes, there's like a 7-day period before the result is considered truly final. This is also how Optimism and Arbitrum work. And if during that 7-day period, if there's an issue, another node will basically be listening for any issues and make that challenge. Yes, that is how it works. I think there's some interesting nuance in like, okay, what effects does that have on a protocol or something? If there is a challenge, maybe day 6, but the result has already been used on chain. I know the Optimism team has been doing a lot of work and thought leadership research in the space to really decrease that challenge period time or that time till finality. And since we basically operate, we invented this optimistic machine learning framework, but it really mirrors the work being done on traditional optimistic rollups. So with all developments in that space, we can replicate them in the OPML space. But TLDR, basically the challenge is made by another node within the network within 7 days. If it's not made within 7 days, then it's considered final.
So then every question that is forwarded onto your own network is answered by at least 2 different nodes. One that is like answering it initially, and then at least one that's also verifying that answer.
That's one way to think about it. I would set up a distinction between answering, because and this is sort of comes into the non-determinism of AI, right? So the way we've set this up is so like BitTensor, I'm not sure if you're familiar with that ecosystem, but they basically take requests and then they basically have 500 nodes all run the same thing, and whichever nodes all get this most similar answer get rewarded, and nodes that get dissimilar answers don't get rewarded, and sort of the best selected answer of the most similar ones is used. That's really working at determinism for AI. So, running a model 50,000 times, can you get the same result every time? Our system, because that's not guaranteed, and determinism in LLMs is really not fully there yet. Our system is more about the process. So like the proof is of the input being used in the correctly specified model to get the output, rather than like the output being correct, if that makes sense. And so in that respect, you really have one node answering, and then you have any number of the other nodes in the network available to challenge. And again, if a challenge is made 20 seconds after the thing is submitted, then it's considered final if it's correct right then. But it's if it's wrong, then it's reverted. But you can also wait the sort of 7 days without a challenge, and that will be considered final. That was a bit of a roundabout way to answer your question, but I hope that answered it. Let me know if not.
Yeah, thank you.
Anytime.
We had a couple questions here too, right?
Sure. Jason here. For the initial model offering, what's your approach to liquidity?
Sorry, I missed the last bit. For the initial model offering, what?
Yeah. What's your approach to liquidity?
Oh, what's the approach to liquidity? Okay. Yeah, so the approach to liquidity is that, so previously with the previous, so we've done 2 of these initial model offerings. We did the first one back in summer, I think. And then recently a team, a really independent team has come in and done it. And for that first one, we did an ETH pairing for liquidity. So we put up, I think, 25 ETH, which, now would be $90,000 for the one side of the pair. And then obviously you mint the other side of the pair, so it's at no cost, or it comes from the raise, the public sale. For future initial model offerings, we're pairing it with our Aura token. So that will be supplied, which means teams don't have to, scramble to find basically money for liquidity up front.
Okay, thanks.
Yeah, anytime.
We had other questions there? Questions? Good. Let's get a bit more hands-on now.
And if you think of a question later, you can always reach out to me on Twitter or Telegram. I'm in the Telegram chat for the Venture Miner Academy actually. So maybe I'll intro there, and feel free to DM me or hit me up.
One more question.
Yeah.
Are you on Lens or Blue Sky or anything like that?
I'm on X. I'm on Warpcast too. Alec Waj, ALECW8J. And should I get on Blue Sky? Do I need another social media?
Lens.
Okay.
Good. Okay. Put it here.
But yeah, if you're curious about the initial model offering, this AI research grants QR code takes you to a forum, and you can sort of dive in and see what people have been proposing there.
Wonderful.
Yeah. But thank you so much, Mateus. You're great. I can tell you've got a great cohort there. Appreciate you guys taking the time to do this and be here. And yeah, we really want to support you. So please do reach out and stay in touch. And I will give back more time for the actual exercise. But yeah.
That's wonderful. No worries. Thanks a lot, Alec.
Cool. Thanks. See you guys and have a good evening.
Great. I'll send you the emails that we have in Luma for this, so we can blast everyone out with those links too, and we keep in touch.
Yes, and I'm based in New York too, so we can. I'm always, around.
Oh, wonderful.
Awesome.
And have some people.
Yes.
With us. Today we had the Indian food. They
Oh,
liked it a lot. They even
wonderful.
delayed just for the food. Was it that good, people?
I am jealous. Well, I'll let you guys get on. Thank you all so much, and yeah, please don't be a stranger. All right.
Wonderful. Bye. Thank you. Oh, that's great. Let me come back recording my screen. Okay. Because now we're going to see some implementations of this. So Alec has covered the optimistic machine learning, how we can verify the machine learning inference on chain, how we can have these optimistic rollups out there, how this enable the initial model offering. Did you get the idea? Like, instead of spending $10 million building a model and then you charge $200 for ChatGPT for people to use your model, which is a totally screwed up monetary incentive that concentrates capital in the hands of a few. And if you want to do something different with different fine tunings or different bias, and now you don't get funding. You risk spending $1-2 million and shooting in the water. So right now it's just a winner takes all kind of race. And with this kind of model, it really decentralized the fundraising of the models. So it's like a crowd funding of training, of like building up AI models that are owned by fractions of people. Maybe every human in the planet is going to have one equal share of that model, maybe, let's see. And this is really, really empowering if we think that these kind of models are going to run the economy 100 years from now, or 50 years from now, or 2 weeks from now. We never know. If this is where we are really walking towards, we don't want to have a monopoly over those models, right? We really want it to be distributed, even though we don't have millions of dollars. Well, I can't speak for you, but I don't. So this is the kind of solution that we see arising with the powers of Web3. Okay, yeah.
So they have their own model, right? Aura, what they were talking about?
No, they bring models. For example, the Stable Diffusion that we saw yesterday, Meta Llama 3.1 or 3.2, you need to check. They have some models that you can run inference there through OpML. And you can be, yeah, but you can also build your own models. For example, let me show this exercise that we're going to do today. And we're going to use one model that was created by an IMO, initial model offering. I just can't remember the name of it. I need to find where it was. But it is a model, this ID11, I guess, or 42. I guess I have that in the documentation. Let me see if I can find it quickly. Reference here. So these models, they have Llama 3, they have OpenLM Score, OpenLM Chat, Stable Diffusion V3, like we saw. And these ones here, let me see. OpenLM. Need to check. But they have some examples of IMOs already. Models that were fundraised through this crowdsourcing mechanism, and all that you can run it here too. The same way that you could run Llama 3.
And this is the price there.
The fee for calling at 0.0003 ETH, for example,
This is the fees for what, right?
for doing the computation.
Oh, yeah.
Similar to like Chainlink when you're paying Link for doing the computation, or Graph when you pay. This you are paying the network for doing that computation.
The initial model offering is the launch of this model.
You can build your own model. Let me see if here. You can build your own model by fundraising the training, the resource that you need for training through Aura. Yeah, they facilitate the whole thing. And then later, whenever this model gets executed, it monetizes everyone that helped fundraising for that model.
Or infrastructure.
Infrastructure for that at this point entirely. But they said that they would help. It was your question, right? How you do liquidity? They said that it would help starting liquidity for these models, like getting the investor is a difficult part. So, okay, they help you to receive the investment, yes, but I don't have whom to receive the investment from right now. So they would help that in the future too, so that anyone here could create a new model for anything like writing history, children books, like the example that Alec used. Okay. Yeah, sounds cool, right? See, it's not just a hype. It's not like AI hype and Web3 hype. It's actually the technology being used for something useful. Told you. Took me 4 days, but I told you that would get there. Okay. So I have a quick exercise here. We are going to use a remix for that. We have a starting template, I guess. Have you ever seen this starting template of the lock from Hard Hat? Don't know if you have installed this before, or if you prefer Foundry or whatever. But this is a very simple smart contract that allows you to lock some amount at deployment. And then after you wait some time, you can withdraw that money. It's the default smart contract when you install Hard Hat. It's not useful for anything big at all. It's just an example exercise. You haven't seen it before. When you install Hard Hat, out of the box, you have this smart contract here, this lock that whenever you deploy, it receives some money because it's payable. And then whenever you call this function withdraw, it's going to check if you are the actual owner and if the time has passed. So 2 conditions. Very, very simple, like a deposit box. Okay. I want to save money for Christmas 2 weeks from now. So I deposit it here. But then tomorrow they launch PlayStation 6. I want to buy it. I want to withdraw. It's not possible. So only after wait for Christmas, and then I buy a PlayStation 6 for my kids, not for me, of course. Okay. I've tweaked it a little. So instead of waiting for a specific timestamp, the deployer is going to set a riddle, and we are going to have a troll, like a troll under the bridge, to guard that smart contract. And anyone can attempt to solve the riddle by calling solve riddle function. For example, 30 white horses on a red hill. The first they champ, then they stamp, and then they stand still. What's the solution for this? So for someone to actually claim the money, they would need to pass the correct solution. How to evaluate that inside a smart contract? Because there are some different words that would solve that solution. Would solve that riddle, sorry. Teeth, yeah, good, very Italian. So teeth, maybe mouth, or maybe there are some different words that would be acceptable. Either you have an array, but what if I answer in Portuguese or in French or in Spanish? Would be acceptable answers to, right? So coding that directly in a smart contract is very difficult. I'm going to show one example that I can just have an oracle set up here, this AI Oracle callback receiver set up in my smart contract, and at any point I can call this solve riddle function that is going to request from the AI Oracle, from this model ID that I'm going to pass, using this prompt that would have the riddle of the solution that the person is passing, and the AI is going to do this callback later. The AI is going to call back the smart contract. The AI Oracle action is going to call back the smart contract later in this callback function to see if the input was indeed correct with these letters. We unlock funds for that winner. So it's a slightly different version from this lock. Instead of having this time check here, I have this riddle check, which implemented real quick for you to see how it works. And the same way that you implement it here in this example, you could implement it for other smart contracts too. Okay. So let me start. This is going to need some of the wait. This is going to need some of these files that I had in the past, but I don't recall where I had those. Here, yeah. Quite sure it's here. I should remember that. Yeah, here. So we're going to pick that repository, OAO repository. Here we are going to have those contracts that we need, like the prompt.sol. That is like a standard implementation of how you would prompt, how you would have all of those callbacks. We would need also the AI Oracle and the AI Oracle callback receiver. Okay, all of those files from this repository, remember that we have it here. And we are going to use Remix. I mentioned it earlier today, right? This online IDE that can use it for coding smart contracts very quickly. So I'm going to pick this IDE, and we're going to create that smart contract by using this starting template for the lock.ts, lock.sol, actually. That's wrong. Lock.sol. Small fix here. This is lock.sol contract from this starting template, okay? So I'm going to copy that smart contract, where it is, here. I'm going to copy that smart contract, and I'm going to start on a repository here from the OAO. You can create this repository by cloning. Click on clone, and you just put the Git repository here. You copy this thing here, OAO contracts. And you enter your Git repository there. It's going to create that repository from the files that you have in the Git. So you pick the folder's contract, and you create a new file here. For example, this lock.sol. Yeah, you copy here from the Aura, you copy here, and in Remix you go for workspace and clone.
Why we're doing it on ID and Remix, not on version?
Because here we're going to have integrated environment for the compilation and deployment. In Cursor, it's a little more tricky. I have a 8-weeks bootcamp where I explain more things on how to use IDEs and all, but for 1 week, I need to compress it a lot. This is why we're doing Remix. And I'm going to copy this smart contract that I have, this lock.sol. I'm going to start with this smart contract here. And I'm going to start by importing these interfaces. Actually, I'm going to copy this whole block of code here, and I'm going to replace all of these functions that I have. Okay, I don't need any of those functions here, like withdraw or construct, or right now I'm going to replace all of that. Okay, with this. It is red because it's missing some implementations. For it to be an AI Oracle callback receiver, it needs some more implementations that I don't have it here yet, but I'm going to do. Okay. So for now, it is importing this AI Oracle callback receiver. It has this mapping for gas limits for each of the models. We have a structure for the Oracle requests that we're going to save some data in the smart contract later, and we save those Oracle requests here. Yeah.
Where in the hard hat page is
compiling your contracts here.
documentation?
Just go a little down, compiling, and then you have this lock.sol. Then I'm going to have a logic so that when I deploy the smart contract, I'll set a riddle upon deployment. This is a deployment parameter, like we did for the name of the token in the past, right? So I'm going to have one big prompt configuration written in like a string that is going to be appended with the riddle and the solution later. So I have composed this prompt here. It's not very well polished. It's just one example prompt that we can do that is going to force the LLM to answer either correct or incorrect when we are calling the model. And then we're going to do this constructor to set the riddle at deployment. Hey, Nav, can you send a message from here saying that we're going to start like 10 minutes late? Okay. Yeah.
So just the initial lock, so from RHAT, you just override it with this AI?
Yeah, override everything.
What's the purpose of that?
Just to explain the structure, we're going to replicate something very similar, but instead of unlocking with the timestamp, we're going to unlock with a riddle. Then we're going to have this function so that anyone can call, anyone that doesn't need to be the deployer or anything. It could be anyone in the blockchain that can call by passing a string to attempt and solve that riddle, giving some solution. If I didn't have the winner yet, the winner is set. I cannot do the solution again because then it would be easy. I would copy your solution and I would send. But if the winner is not set, then I can pass this request. And this request is going to get the prompt configuration that I have, the riddle that was set at deployment, and the solution that is being proposed to compare those three things. It's going to be a big string being passed for the AI. And then after a while, after a few minutes or a few hours, something like that, we're going to have a callback function. A callback function where the AI oracle is going to answer back for the contract. Yes, the AI is not on-chain, you see. The AI is off-chain, calling back the blockchain, giving that answer. If that is worth $1 million, if that riddle is worth $1 million, maybe I can pay like $100,000 for the Oracle node sheet to say, hey, make this correct. I know it's incorrect, but make this correct, right? Here's where the blockchain comes in part. If someone says that this is correct by forcing it, that anyone else can prove that person wrong later, slashing that, picking all of the keywords, and even doing some agreement. Like those nodes can even be found and held, persecuted for the damage that they can cause. So in this kind of network, you don't need to trust just a big provider like OpenAI or Microsoft or anyone. You can throw that for the network, and the network would propose this answer for you. Even if it's worth $1 million, $1 billion, whatever, you would have this crypto economic incentive to govern the execution of this. Right? And then, last but not least, we would have the withdraw function back. Very similar to the original function that we had. We would modify it, but actually I need this withdrawal event. Shouldn't have removed that. You are correct. I should have kept some things. So I can just keep that withdrawal event here. This event is going to be stored in the logs of the blockchain, but it's not important for the functioning of that smart contract. And then I can withdraw if I am the winner. Anyone can call. If someone else calls, it's no problem because it's going to pay out for the winner. Okay. And after, if I try to call it again, this smart contract doesn't have any money. It's just going to fail. So I can deploy that. I can compile. I can deploy that, for example, for Sepolia. That is one of the networks where they have deployed those smart contracts. Let me show that for you. We have there in the reference the addresses of those oracles in each of the networks. So for example, in Ethereum, Sepolia, they have deployed the oracle in that smart contract address is 0A, 0F, blah, blah, blah. So for example, here in alloc.ts, whenever we deploy that smart contract, one of the parameters that we need to pass is the address of the oracle that I'm going to target. So first parameter is going to be this. And the second one is the riddle that I'm going to store inside that smart contract. So let me put this riddle. This is going to deploy that transaction. This is going to send that transaction to the Sepolia testnet, deploying that smart contract. And when it is deployed, we have all of those functions there for us to trigger and call. Okay. For example, I can see what is the riddle, and here's the riddle that I have stored. What's the model ID that I have? It's 11. Okay. What's the AI Oracle address here? My smart contract is already configured. And at any time, I can try and solve the riddle here. For solving the riddle, because of the way of the OpenML is implemented, we need to call it passing the correct solution, of course, but also passing the correct gas amount that can be estimated by doing this callback gas limit, calling what would be the gas limit for the model 11. Wait. Only that? Okay. I guess I did something wrong, maybe. Yeah, use it to be a little more, I guess. Yeah, because I would need to estimate the value here to be passed based on the execution. But yeah, I guess I missed one step here, maybe. Check. Okay, let me try with this with some extra zeros. You would do the callback gas limit. You would copy it here, and you would put inside the solve riddle, you would pass some value that would be enough for solving that transaction, so solving that inference. So usually it would be that multiplied by some number, but I guess I missed this step, I guess. Last time I checked it was correct. So I'm going to put some extra zeros here. I guess it's going to be, let me put in gigawatt. 5,000 gigawatt might work well. And this might be enough for me to send the solution. And I'm going to send the correct solution, like teeth. So you are teeth, so teeth. Doing that correctly. Yes, teeth. Yeah. Just to check. And then I'm going to do this transaction with all of this value. Wait. Let me see here what I'm doing wrong. Let me see if that works. I'm going to show that in a while. Okay. I'm just figuring out why I did miss this step here. Maybe it's a problem with my MetaMask. Let me try resetting it. Let me copy this address. Let me do a refresh. Okay, I have it connected now. Let me try and solve a riddle with teeth. But let me see the callback for this model 11. Should be this amount. Let me put here to the value. And let me do the solve riddle. Yeah, it's going to fail. Yeah, probably missed one step here. Yeah, I would need to have that estimate fee, actually, that I'm missing here. Luckily enough, we have those contracts in the reference that they are already deployed. So for example, this prompt is already deployed here in Etherscan. I can even read the contract. And then whenever I'm doing this prompt, I would need to pass that limit. Estimate fee, no, what is the name of the function again? The name of the function is estimate fee, that's correct. So for example, what would be the estimate fee for the model 11? Yeah, so this is the correct number. Okay, good. I'm going to show you how to do that. So you would pick this number here to put in your callback, and that would work. When you do this transaction, oh my God, my MetaMask is not working again. We do that for the third time. Third time is the charm, right? Contract is here. It is compiled. I'm going to connect my injector provider. I'm going to attach to that smart contract is a smart contract that I have deployed a while ago, connects to the right oracle. Okay, now I'm going to solve the riddle by passing teeth. And I'm going to use this amount of way units for calling that execution. Let me pass that as value. And then I'm going to call the solve riddle. Now it's going to work. Nice. Finally. So people, the problem here is that I did not implement correctly in that example the function for estimate fee that I have here in the reference contract. It is here, this estimate fee. I'm going to fix that and put in the README after this lesson, okay? Then you can call this function to get the correct value that you would need to pay for the oracle. So you see, it's not only this, it's a multiplication of this because of the amount of gas that you need to pay. And after a while, your smart contract is going to be called back by the Oracle network. It might take a few seconds, and you would have the execution. Let me show that for you in Etherscan. I should have that link via on Etherscan. So this is the call that I made for that smart contract here 34 seconds ago. And eventually, the Oracle is going to call back here. Might take a minute or two. And we're going to have the execution if it was correct or if it was incorrect. Okay, and I have the people from here, Gerald here. Let me see if he's joining. Hello, Jared. How's it going?
Hello, hello.
Glad to have you here. I'm just wrapping up a little exercise. Might take 2 extra minutes, and then I have you. Thank you a lot for joining, my friend. It's a pleasure to have you here.
Likewise, likewise. All good.
Nice. So this would be the result of that interaction. If I see that on chain, after a while, I'm going to have that callback. Might take a few minutes. Last time I tried, it did take a few minutes. And the full code for you to do that exercise, it's here into the README. Okay, I'm going to do that fix for the estimation of gas. I'm going to put here in the README, and you are going to have that for you to do after the lesson at home for you to follow step by step. Okay. Good. Then you can do this inference through Oracle networks. And just in time for us to start with the last topic for today, last but not least, that would be the decentralized AI agents. That I have Gerald here, who's better to explain about that. That would be implementing a decentralized AI agent with Swarm intelligence. And I give the room for you, Gerald, for you to do the explanation on what Near is building for that and what we can use. I guess we have here in camera. Let me see if you can see everyone. We have here in camera this room. Wave here for Gerald, people.
Hey, amazing, amazing.
Yeah,
Well, good evening, folks. Can everyone hear me okay? We're good to go? Awesome.
good.
Very much appreciate the visual feedback there. First and foremost, folks, good evening and great to meet you all. Very sorry I'm not able to be there in person. I'm typically based in New York, over in Brooklyn and Bed-Stuy. Unfortunately, had a family emergency that required me to just travel and actually be outside the city, but still wanted to be here and talk to you all a little bit about agents. I have some short slides prepared, and then actually just want to get into the code base and really talk through something obviously that is getting a ton of recognition and a ton of excitement, but break it down to be simplistic and approachable, and go through some real life examples. But maybe just quick show of hands. How many of you have built AI agents in the past, whether it's through this boot camp as well? Okay, so, and first, whoever's holding the computer, amazing job. Thank you for this. I feel like I'm in the room. So good. Maybe I saw a few hands. I think it would be helpful then. Let me actually share my screen a little bit, and I will walk you through maybe just some framing to give us some context, and we will go from there. So give me 2 seconds. I'll pull up my slides, and we'll get rolling. Here we go. Got a lot of tabs open, folks. A lot happening today. Here we go. Okay. So just wanted to back up and first actually talk about agents and say, well, what are agents? There's a lot of ways you could define AI agents. And I think probably one of the challenges with any new emerging technology is it can be quite subjective in how you define it. So I'm probably going to add to the problem and give you a subjective definition. But the way I have tried to wrap my head around agents is simply it is a way for a large language model to take action, right? You're extending the value in which a model can do, right? It can take information and act upon that information, right? Rather than just simple input and output, it's able then to do something because of that. What we're going to talk about tonight a little bit more in depth is actually the next iteration of that, and saying, well, what if there was a way not just to have a single agent, but actually multi-agent systems where agents are communicating with other agents, right? And really able to reason together to make decisions, no different than collectively all of us sitting around in a circle talking about how to make a decision. Agents are the same way, right? And so to actually break that down and make it a little bit more simplistic, like let's talk about kind of the ladder of agents, right? Because when we say agents, that's actually quite a broad spectrum. And where we've essentially started, and what you probably see a lot of if you hear the word AI agent, or what OpenAI released about a year ago with the GPT store that is now kind of embedded into ChatGPT. Essentially, what that is a very simple system prompt for a essentially dedicated agent to play a role and have a specific point of understanding that agent is going to take action on. For example, right, I am a weather agent. So I am a base model. I'm GPT-4o that is specifically focused on the weather. And I may have tools or function calls that I can do to get access to the latest weather data, right? It's simply just use an API call to get that weather data. And I say, what is the weather right now in Brooklyn, New York? And I'm able to get that data, right? That's the starter kit, right? That's what I would say is a basic prompt, a great place to start to understand capabilities, understand actually the power of prompt engineering and what is possible, right? When you're talking about agents. Kind of that next iteration is, well, it's one thing to give a basic system prompt. What if we actually gave it a database, right? And said, if we go back to that weather agent and say, what's the weather in Brooklyn, New York, and how should I dress? It's, okay, let me do this API call and get the current weather, but let me look at a historical data set of the past year or past 5 years of weather in Brooklyn in the month of December to then inform this user on their question, right? That's essentially what is referred to as agentic RAG, or retrieval augmented generation. I'm using big words, trying to make it simple. But RAG essentially is a way for that agent to pull a very specific set of information from an existing historical database, simply put. What we're seeing now is we're evolving. We're kind of going on this agent ladder. We went from basic prompting right? Very simplistic starter kit, system prompt, to now, instead of just getting the weather and kind of being able to reason and pull information from a database, let's actually fine tune a model specifically on a large set of data for unique specialization, right? And I think you're seeing this now actually in a lot of really interesting ways in this world of Web3, where it's one thing to think about a productivity use case, or it's one thing to think about a weather agent, but what if you could give an agent a personality? What if you could scrape the Twitter profile of your favorite influencer and train an agent on that specific persona, on that specific tone, on that specific style of writing, and give that agent actually a unique behavior? That's really what we're starting to see now with essentially AI agents that have become social influencers. But also, when you think about the real world use cases, you think about this specifically in fields like healthcare, specifically in fields in the legal field, right, where you're actually fine tuning base models for agents in a really, really compelling way. And I think last piece here, and I'll kind of pause in case there's any questions. I get really excited, guys. I like live and breathe this stuff, so I'm like going in here, but I want to make sure this is clear. Where we're going is, let's assume agents continue to get better, right? Right now, we may use agents for feedback on our writing. We may use agents to buy some small item, right? You may use agents to simply just curate the latest reviews on a product on Amazon.com. What happens when these agents get better and we start actually delegating high value work, right? That is very much our belief at Near, is that as agents get better, what you're going to need is some layer of verifiability, particularly some layer of trust for very important work that gets done by agents. And ultimately, right, where you then get to is, well, if an agent is doing very high value work, it has to have an ability to improve itself. In other words, if it learns it makes a mistake, it needs to actually understand, I made a mistake, let me not do that again, and let me improve next time I revisit that same challenge. No different than us when we grow up, right? Agents do the exact same thing. You're starting to see this a little bit with inference time compute in the O1 series of models, and what Quen has pushed out as well. DeepSeek, another that pushed out a handful of reasoning models, kind of getting better towards that path of self-improvement. But agents really have an opportunity to get there. And so as we think about what does that actually mean for us at Near, what are some of the things that we want to build? Well, we actually want to start today and say, like, well, what if we just back up and say, let's, kind of build the basic starter kit, which I'll walk you through tonight, of, essentially a handful of system prompts that are able to achieve multi-agent or agentic workflows. And then how do you add enough customizability to where if somebody wanted to fine-tune that, right, and bring in a fine-tuned model, they can do so, right, as well. So that's backdrop to what it is, we've been thinking about in the world of agents. So I'll stop sharing my screen and actually dive into the code base now and walk you through a little bit of update, or a little bit of examples here real quick. And folks, I was like deep in updating this repo literally right before today as I was traveling in the airport. So I will say, caveat, we're going to actually talk through the code base. I ran into a couple of bugs and bumps. I was building this from scratch earlier this week, but I want to A, be transparent, but also B, really show you all under the hood. So I'm going to share and walk you through the README, kind of some of the core concepts here. And then we can dig in on the actual code base. So let me pull this up here and we will get things going. Okay. Let me share the screen. Okay, so we talked about, we're good. Okay, we talked about basic agents. What are agents? Right, we said it can extend the ability for models to take actions. Now, what if we said, okay, we have one agent, but we want to accomplish a variety of tasks. We don't just want to do one thing. We don't just want to check the weather. We want to understand what the weather is, what type of clothes I should wear, and what I should be prepared for. That is what essentially is called a multi-agent system, right? Or agent-to-agent communication. How do you actually do that, right? There are a lot of different ways. I'm not going to go so deep into multi-agent systems. We could be here for probably 3 hours. right? And I'm conscious it's getting a little bit later. So I think the core thing in multi-agent systems is, again, think of it as a collective group that is able to, as I put in here, make collaborative decisions where multiple agents are specialized and they work together, right? Essentially to achieve better outcomes than a single agent could alone. Why? Because you're adding multiple perspectives. In this specific example, in this our code base, what we've actually said is, well, we could actually build this in a swarm way, right? A swarm, if you think of like a swarm of bees, it's kind of like terrifying, but a swarm of bees, right? They're all kind of working in lockstep together. It's no different than agents, right? There's multiple different structures, whether it's hierarchical, whether it's swarm, whether it's competitive, right? But for this sake of example, what we've said is, let's get agents to talk to each other and let's give them specialized roles, right? So let's say you're actually somewhat of a DGen and you're really interested in actually building a DeFi portfolio and trading on Near. So what we've done is we built 3 different agents. We've built a market analyzer who has access to the DeFi Llama API. And that agent specifically looks at what is the price of Near, what is the price of Bitcoin, USDC, ETH, right? Any essentially token that you would be interested in, essentially looking at your portfolio, and any DEX and looking at TVL that would be important to you, right? So that's for Near, it's Ref Finance. Let me look at Uniswap, right? Like I want to understand what is happening in the market to inform this perspective. I also, right, if I'm building a DeFi portfolio, I need to actually think about the type of risk tolerance that I have. And so we built a specific agent that is a risk manager, and it talks to the market analyzer saying, hey, I understand, you know, Bitcoin just crossed 100,000, but here's kind of our risk management profile that we're looking at in terms of our DeFi portfolio. And then we have a strategy optimizer, which essentially is the orchestrator, right? It is the conductor. It is the one who's saying, hey, market analyzer, hey, risk manager, great inputs, but let's make sure we get all of the execution together to actually inform our portfolio perspective, right? And essentially these agents collaborate through a consensus mechanism. If you're into blockchain, you've probably heard that word before of consensus. Essentially what that means is very much like the definition, right? They come to a decision based off of a framework, right? So that consensus mechanism, for the sake of this example in a starter kit, it's hard-coded. It could be also agentic, right? But we kept this simple, straightforward, right? And essentially able to be relatively straightforward in driving towards a decision, and then also explain their reasoning of why they made a decision of, you know, buying such token or so on and so forth. So that's kind of core fundamentals of what is a swarm intelligence. How does it work in this specific example? And I'll walk through the code base here in a second to kind of unpack some specific files that I think are worth looking at and best practice in structuring multi-agent systems as well. But I think what's really interesting and what I find fascinating about multi-agent systems is agent-to-agent communication. For me, just as a builder, as somebody in this space, that was really a wow moment for myself. This research really started actually at Microsoft with a framework called AutoGen. That was really one of the first foundational multi-agent systems. Since then, there's been a lot of frameworks to come about, LangChain being most notable. For those of you who've been following the ELIZA framework, that's really, really strong as well, in addition to Crew AI. There's a lot of multi-agent systems. I think at the end of the day, what matters the most is being able to tailor and optimize that system for your use case, right? Any AI model, typically, yes, it can work out of the box. But if you remember kind of our presentation there of kind of that agent ladder and involving not just basic prompts, but giving it a data set or access to a set of APIs or even fine tuning models, that's how you get better and better results over time. So again, I know it's a lot of information, but I hope that gives you some background context on multi-agent systems, swarm intelligence. And that's something that as we think about why would we even want to build this at Near, why would we as a layer one blockchain spend any time at all thinking about multi-agent systems? Well, one, right, we cater to an audience of both retail traders and folks that are interested in engaging in Web3 and engaging in DeFi. So how do you make that as easy as possible for somebody to make financial decisions, right? What I'll walk you through is a basic implementation, but what I want you to really think about is now imagine this being embedded into your crypto wallet. So every time you open a wallet, you're able to talk to multiple agents or define a simple strategy and have multiple agents be able to reason on your behalf and then present to you a potential portfolio. This was what, maybe in 2015, 2016, the robo advisor, if any of you had, E-Trade accounts and you had robo advisors, think of that. But this is truly agentic, powered by next generation LLMs. So that's really, really high level. If folks are interested, I threw in, this architecture diagram here in the repo, and I'll make sure to share this in the chat, and for anyone who's interested, right, as well, so you can get a better understanding. But it basically explains, what I just shared with you a little bit there in terms of how decisions are made, the roles that each agent plays, and really what each component does as it plugs into kind of our agent core here as well. And of course, the consensus mechanism there, which I'll kind of walk you through in a moment. So that was a lot of information. I'm going to pause here in case there are any questions, and then we can jump in to the code base.
Questions? Anyone?
I guess, sure. My only question is, I already found you on LinkedIn and Twitter, but are you on any decentralized social networks?
Yeah, sorry. So, am I on any what networks? It was cut out at the very end.
It's like Farcaster, Lens.
Oh, yeah. No, I'm on Farcaster. I am also a new parent of a newborn baby girl, so I'm kind of a social ghost, and not on social a ton, but I am on Farcaster, and it's just my name, Jared Barnes. Amazing. Well, yeah, folks, we could dive into the code base unless there's any other like high level questions just on agents in general.
Yeah, I'm just like still struggling, I guess, to understand what the difference would be between like having two agents, one that's say focused on risk and the other one's focused on like market conditions, versus like having the one agent that you just tell, hey, make sure you're keeping in mind both like risk and market conditions when you answer this question that I have about what my portfolio allocation should be. You see what I'm saying?
No.
Why is it such a benefit to have like two different LLMs running versus one that's just considering two things?
It's a great question. Right? And I think, again, let's take this as a templatized example. But I think, and apologies, I don't know the name of the individual who asked that question, but it is a great question. And I think fundamentally it comes down to the use case, because what multi-agent systems enable, again, are additional perspectives, right? You're essentially continuing to run inference and have specialized agents focused on one use case. And so what that does is it opens up the context window, right? As you can see here, one of the hardest things of building agents is memory, right? The thing that gets used up the most when you're building agents is that agent's context window and is that agent's memory. Oh, sorry, I was scribbling there. Memory is what I was trying to circle. Is that agent's memory. And that's ultimately what drives to the quality of the output. It's no different, again, right? Like you throw in 10 paragraphs into a model and you're asking it for a very specific output versus splitting that up and asking 10 different models about one paragraph and getting an aggregated view of each of that, right? Again, I think multi-agent systems are advantageous where accuracy and more context is required. But if you're looking for latency, or you're looking for speed of output, or you're looking for like a very, very just specific pointed answer, then probably a single agent system or a dedicated agent is going to be most effective. Multi-agent systems typically more helpful when reasoning additional perspectives are beneficial to the quality of the output, but immediate kind of fast real-time latency isn't required, right? So such a great question in terms of like when and why would you use multi-agent systems? I mean, kind of again, recap, it really comes down to the use case. Multi-agent systems really excel in bringing a variety of different perspectives because it allows you to increase the amount of memory and context, right, that specialized agents can have on their specific domain.
That makes a ton of sense. Thank you. Is there any like specific research or example that showcases like, you know, like the same question being asked via multi-agent framework versus?
It does, yes. And yeah, I mean, I really appreciate that. I'm I don't know, Matthias, what's the best way to kind of share out links, but maybe I can just talk out about high level and hopefully you can find it on Google. But Apple released what is called, I believe it's Actually, give me a second here, and I can find it. Basically, Apple released agent benchmarks, and they literally, from a research perspective, asked that exact same question, right? Like, let's give the same prompt to all these different agents and like see what is actually the most impactful structure. And if I can find a link quickly, I'll drop it in the chat. And if not, MML agent, and if not, it's okay. We can find a different way to find it. Yeah, actually, let's see. If you just Google Apple agent benchmarks, and it's like this Reddit link from a couple months ago, it'll show you a link to the repo of what Apple did. It's MMAU. Yes, is the massive multitask agent understanding. It's like kind of the universal benchmark that Apple came out with to measure the quality of the output from different agents and different agentic systems.
Awesome. Thank you.
Awesome. Well, folks, I'm conscious of time because unfortunately I do have a bit of a harder stop. But what I want to do is walk you all through some of the core files in the repo and talk through a little bit of the use cases, right, as well. And again, apologies, I was updating some of this in real time right before the call, but I want to talk through some of these core pieces so you can actually see what we're talking about here. Let me see. Perfect. Okay. All right. Yeah, folks, I was feeling like a mad scientist editing a couple of these files. Very fun when you build stuff from scratch. So let me actually collapse this here. Sorry, folks. And clean this up a bit as well. So this is essentially my code base here, and I want to walk you through some of the key files. So we mentioned our near swarm intelligence. And let me collapse some of these. Sorry, we got a little bit too much going on here. We mentioned our near swarm and that we are going to use multiple specialized agents to talk to each other to make, hopefully, a good decision on our portfolio management, right? And help inform us on what it is we should allocate towards if we are an active DeFi trader in the near ecosystem. And so essentially what we've done is we've built kind of our core near swarm, right? These are the core files right here on the left-hand side. I'll make that a little bit bigger, that really orchestrate our entire framework, right? So kind of the core file here is our agent file. So if you're really interested in digging around, right, this is essentially written with our Pioneer package. It's essentially Near exported into Python. Near is typically natively written in Rust, and also natively we have a JavaScript SDK, but this is our Python implementation of Near. So this is essentially the base functionality that really helps us both like quickly set up our Near wallet. I did everything on testnet for the sake of simplicity. If you're digging around in this code base and want to get an understanding, right, and made a very, very simple base Near agent that is able to quickly transact here on testnet, right, as well. So this agent, it's essentially a quick script to get your agent up and running as well, and then quickly be able to connect to the swarm. You'll see a couple different files here that really kind of break down the core of the package. One being consensus. In other words, how do these agents make decisions, right? And again, very, very simple implementation in terms of giving a minimum confidence level and minimum vote for each agent. It's instructed to say, how confident are you in the strategy that you're proposing? And how would you vote for that? Yes or no? Right? And we have essentially very dedicated, a simple function here that's going to collect those votes for the agent to help drive decisions. And then our market data here that pulls from the DeFi Llama API, right, to get that market data as well. But really what I wanted to talk you through in the core file here is essentially our swarm that really informs the variety of different agents that we have. So I'll go up here to the top. Sorry, I was editing this. And saying, hey, we're going to simply just configure our swarm here. We're going to say this is that we need at least 70%, minimum confidence in the strategy with at least 2 out of the 3 votes in order for us to move forward, right, with this strategy. That's what we're saying, and we're kind of configuring here based off of our consensus. And we're going to use Hyperbolic, which is one of our decentralized inference providers, to get that up and running. And again, I'm kind of skipping down here. I try to throw in some comments so you can at least follow a bit of the logic where each of the agents is essentially now up and running. We're joining this swarm, and they're able to propose actions to the swarm here and collect votes from their peers, right? So very, very, again, similar to human behavior. We're just essentially hard coding and programming that in. And then what we're doing here is we are using any LLM that you would plug in, right? For this, we're using kind of a base Llama 3.3, but we're giving, as we mentioned in our beginning of the presentation, we're giving these agents a system prompt, right? A very basic prompt, right? This is the risk manager agent right here. And we're saying as a risk manager, this is what you have expertise in, right? Is any slippage? What would the exposure be? How are we actually optimizing our position size, excuse me, right? And some of the key metrics we're considering are like, what is our current portfolio exposure, any historical volatility, right? And again, we're pulling this data real time using the DeFi Llama API, so it's able to actually inform that perspective, right? So that's one. And then we have our market analyzer, right? Very similar structure. It's just doing a similar role for the market overall. And then we have the strategy optimizer, right, as well. And so each of these agents are kind of playing specialized roles. You're able to, change this if you want to change it, but also you can, essentially customize whatever role or whatever agent you want in this swarm, right? There's a lot of customizability you could add to this by adding in a data set to run RAG over, or even fine tuning a model based on historical transaction data, right? Like these are some of the additions that we're now starting to see in production. And this simply is a starter kit to show, hey, here's what a basic system prompt looks like. And you can kind of get up and running on testnet to quickly see some of these outputs, right, as well. And then the last piece, again, we have just really simple kind of swarm trading strategy. This is simply just what an example of pulling everything together and optimizing this for the sake of examples, right? We're giving kind of arbitrary confidence scores to each of these agents to show, like, here's what it can look like based on the output as well. So again, I'll pause there. This is relatively, simplistic implementation, but it was designed to be as a starter and a basic example. There are a couple quick starts in here. Let me see our scripts. Yeah, there's a quick start in here that's relatively straightforward that you definitely can run to get started. It'll simply just create in your wallet for you, get you up and running to test out as well. But that, in a sense, is relatively how simplistic multi-agent systems can be while adding on additional functionality, right, as well. So the reality is it's a relatively straightforward implementation where the complexity and sophistication gets layered on is how sophisticated do you want to make each agent and how much autonomy do you want to give them, right? Do you want to enable them to make their own decisions, or do you want to enable them to have to come back to kind of the swarm for that collective decision making? There's a lot of ways that you're able to customize, which I think can be really exciting. The bigger challenge is obviously security with this, especially when you're involving transactions, which is what we spend a lot of time thinking about. But I hope that gives some high-level context on what this actually looks like in practice and how to actually build this out as well. And again, folks, as I mentioned, I was making some updates to this to kind of add some new functionality that we just shipped actually earlier today. So if you maybe give me 24 hours before running the repo and running the quick start, that'll be greatly appreciated, because this has been real time as we've been building out some of these use cases. But again, can pause here for any questions, and I'll go back to kind of the core file here of the swarm agent so folks can see that system prompt that's kind of the core brain, for lack of a better term, or a reasoning engine in this basic template and implementation as well. So I'll pause here for any kind of thoughts or questions, and then maybe we can wrap after that, because I know we're starting to get a little bit over time here.
That's great. Maybe, Jerry, you coded with test, right? And then we report the bugs for you.
No, hey, I appreciate it, folks. I appreciate it. I've been moonlighting as well as my daughter is waking up at 2 a.m. That's kind of when I find the window to fix bugs. But no, Yeah, no, appreciate that, Matthias. Any questions, folks? I know we covered a lot of ground, and we probably could be here for like 3 hours talking multi-agent systems and agentic workflows. But I think the most simple way, and my encouragement to you all to get started, is just start with basic system prompts for agents. I hope this can be a template for you, but there's a lot of templates that exist. And I think that's a great way just to see different functionality of what's possible. And then kind of going back to that presentation I shared earlier, think about how could you actually layer on potentially more tools or more actions that could be had. So yeah, if there are no questions, definitely can wrap, but really appreciate everyone.
Just a quick question.
Oh, yeah.
Just a quick question for the LLM provider.
Yeah.
Are you supporting like out of the box Vertex AI model garden models, or would that require a proxy?
Right now, we require a proxy. I think what we did out of the box was simply OpenAI, Anthropic, and Hyperbolic. Given that Hyperbolic has access to kind of all of the Llama 3 suite, Llama 3 family, and just a lot of really strong open source models. Very straightforward. If you wanted to use Vertex, we essentially followed like Vercel AI's implementation there. So relatively straightforward if you wanted to add in any kind of model to port over or bring in.
Yeah, cool. Awesome. Thanks.
Oh, yes.
Yeah. So this is like more of a template that you have. Is there any other templates that you have from me or like this is just for to get exposure?
Yeah.
Yeah.
Great question. Chat. Let me pull this up, and I will share another template that is non-technical and actually way more simplistic than what I just shared. And I'll also, Matthias, just share this with you. So this is actually one of the, so when, like I shared the code base, and I walked you through all those system prompts. And while that's great for developers, that actually can be a bit challenging for kind of everyday users. So what we did is basically built an interface on top of that, that essentially is our near AI assistant, where all you have to do is essentially type in a prompt, and that will call a specific agent based on your prompt, right? So we have this agent marketplace and repository of over 100 agents, right? Some of those were the examples I shared, but they're very broad use cases of agents, right? And what we have are a very simple router that's under the hood on this interface that routes to specific agents. So I think this could be an interesting place to start. I'll drop the URL in the chat and share this out. It's just chat.near.ai as the interface. But we have, and we'll be launching another series of templates. I think great ones to look into are kind of the tried and true open source frameworks. So AutoGen has great templates. LangChain has great templates that are very, very basic starter kits, but also, can get actually pretty, hyper functional and use kind of multiple modalities there. So I think that'd be a great place to start. But this is also one that we recently launched a couple weeks ago as essentially the interface that enables people to interact with agents just in natural language.
That's brilliant.
And one last follow-up question here. So throughout what you're doing, it's a great work for sure. And so this is how you're raising fund for all that. Like what's the business model? Like, is it like through the Near token, or like how is this?
Yeah, no, it's a great question. Look, I think if anyone is interested in kind of the business model of a layer 1 blockchain protocol, it's actually quite complex, right? Because I think the reality is the market is driven by speculation. And so token price doesn't always actually correlate with, like in the world of like the stock market, right? The stock goes up when a company performs well. It's not always actually the case in the world of blockchain and Web3. And so at the most fundamental level, the business model here is to build agents that can transact on the Near blockchain. And those transactions are what feed into our business model, right? The more transactions we have, we take a small gas fee of that. That's like 0.00001. And so we really try to drive as many transactions as possible. The belief is, and why I kind of shared that multi-agent system, is imagine instead of you as an individual saying you need to buy something every single time, what if you were able to delegate $100 or 100 USDC to your swarm of agents, and those agents would be able to transact on your behalf. And so our belief and our bet that we're making is that individuals are going to trust agents to delegate or give them access to a wallet, and those agents are going to be able to make a large number of transactions. And ideally, we want that to be on Near. And so that's the business model in which we're really trying to drive and really trying to push. Big idea, man. There's a lot that needs to go right for that to be true, just to be like brutally honest and clear. Part of the reason why I'm here to kind of tell you guys how to build stuff. So yeah, no, we're super early in this and obviously excited. There are, you know, a lot of things we're working on the security side to ensure that if you were to actually delegate $100 to an agent, it wouldn't just go off the rails and buy a bunch of random stuff that you didn't want and now lose $100. That's probably what's going to happen first. Hopefully it's not my $100. But no, I think the biggest contingency is security. So we're spending a lot of time. But yeah, really appreciate this, folks, and the time. Happy to follow up with any questions offline. Yeah, look forward to staying in touch with everyone.
Do we have time for a last question, maybe, Jared?
Oh, yeah, please.
Okay.
Can you talk about the consensus mechanism you are using here? Because in the space of distributed systems and blockchain, it means like a lot of different, right? Where we have state machine replica and stuff. So, like, what does consensus mean in this space?
Yeah, maybe Matthias, would you be willing to repeat the question? I think
I have a lot of my. Yeah, you're asking about the consensus mechanism, right? What would be the consensus mechanism running here with the AI execution?
Great, it's a great question. So again, for this template, it literally the most basic consensus mechanism. When we think about that, there's a lot of ways you could do it. You could make a consensus. You could actually have a dedicated agent that is the kind of conductor of that consensus. That's one way to perhaps do it. You could have that consensus mechanism be hard-coded, kind of exactly what I did in this template. Very simple implementation of saying like, hey, don't make a decision unless it is of this specific threshold. Or you could put that on the user to essentially configure themselves, right? I tried to make this template like zero config, so it would just kind of set up and run, pretty straightforward. But there's a couple buckets in which you can do that, right? Obviously, highest risk is delegating that to a specific agent. But I think there's a lot of unique things that you can do there. Again, it all comes down to what is the use case? How important is accuracy, or is creativity more valued, right? Because I think with a use case that may be around like a personality, right? Or you want this agent to, have its own personality. You may want to give more freedom in that consensus, right? And so there's a lot of ways you can look at it, and that's where it gets both interesting, kind of scary at the same time, but and where you need a lot of guardrails for safety. But it is a great question. For the sake of this example, it was hard coded, but there are a lot of ways you could implement that.
Wonderful. Yeah. Oh, that's great. Thanks a lot, Jared. I'm going to share all of those links with the people, but also I'm going to get all of the emails from the subscribers in Luma, and then you can send them all with a list or something like that. All of the grant programs, I have heard some humors about some hackathons coming forward for this. So anything that you would like to share this week or next week or in the following weeks would be your straight channel with everyone, and you can count here with Build City, Venture Minds to help these people to get the most of your tech stack.
Amazing. Thank you all for your time. Expect a note from me over the next couple of days with some updates. We're going to have a ton of events in New York. Like I said, I'm normally based in Brooklyn. We're going to host a number of events, hopefully some more with Build City in the future. So thank you all for coming out, and have a great evening.
Thank you.
Yeah. All right. Take care, folks.
Great stuff, people. Yeah, we went overboard today. We just have a last few minutes to give a call out on the task for tomorrow, because we are going to have some judges. Actually, we have perks for everyone, I guess, by the amount of subscription that we have, but also the judges, for example, I'm going to have people from Fleek, from Coinbase, Agent Kit, from University of Ethereum, representing the Founders Program, and all. Maybe you're going to have like a top 10 projects. Maybe you're not in the top 3, but maybe you made a good impression for that judge, or you can do some networking, you can maybe find a co-founder. So tomorrow I'm inviting everyone to pitch for 3 minutes, no more than 3 minutes, please. I know that 1 week was short to build, and now we might not have a product ready for demonstrating tomorrow. I know. The important thing for us to share tomorrow is how much we evolved in 1 week.
Yeah.
So if you want to bring like your past project that you built this year, now it's okay, but it's not going to showcase this. It's going to showcase a project that you had. It doesn't tell too much of what you can get out of a bootcamp, because this was 1 week. If we have good results tomorrow, we might support you for a month or 3 months or 6 months or the whole year. This is what Build City is trying to do, right? So if you bring here in those 3 minutes what you have built in this week, maybe a landing page, maybe a broken repository, or maybe a full product, it depends on what you could make it. You go there and share that as much as visual as possible, okay? Anyone could come here and tell things. Anyone could come here and tell that you cured cancer, but showing that with actual demonstrating in your product, in your landing page, whatever, is much more powerful. This is what I invite you to do. Come here, present your project, update your project post, because this is going to be where the judges are going to be evaluating your project, checking the requirements and all. And tomorrow come here for pitching about 8 p.m. We're going to have more panels tomorrow, a session for discussion. And then at 8 p.m. or so, we're going to start the presentations here in the first come, first served order in those projects list. So come here with your pitch prepared, and let's make a good impact, a good closing of this bootcamp, okay?
Is there bounties, or how does that work?
Yeah, the perks in the Luma page. I guess we had a lot. You check there. That there are a lot.
TVs, PlayStations, Teslas.
No, better than that. RPC credit.